Hello, everyone. I see 11 people have joined. Where is everyone else? Could we please WhatsApp them to join on time? If you can WhatsApp someone who's not here, who you can reach out to, then that would be really helpful. So one of the things I want to really emphasize, I provided a tab or a sheet that people could enter their typing scores. And in the first session, um, I offered some tips on how to improve your typing and how to develop your typing skills. For you to work with computers and for you to be successful working with computers, you have to know how to type. It has to be part and parcel. You need to aim to have a typing speed between 60 and 80 words per minute. But that can only happen if you do it in the right way. It doesn't happen by practice. It doesn't happen by force of will. It happens by doing it the right way. And what I shared in the first session was that there are online tools you can log into, provided 100% free. You just have to practice every day. If you don't practice, you don't develop. So I've seen a number of you have really put in effort. They've been putting in their daily score. I'm just going to share that on my screen for 1 minute. And this is really impressive. I'm really impressed that some of you take it seriously and are really keen to develop your typing. So please, it's for your own good. Look, there's one individual who has been very consistent from the beginning. Love, very impressive. Sylvia, you started and then you slowed down. Justin, very impressive. This is really good. Now, I want to show you what your progress will look like. Most of these individuals, I see that they've actually dropped. Some of them have dropped, and that's exactly what you would expect. If you're learning a new way of typing, you would expect that your old way of typing has to be sort of dismantled in order for you to pick up new skills. And this is ideally how it should look like. You'll start off by dropping, and then you will gradually, day by day, just be adding about 1 word per minute. And it's progressive. Try as much as possible to put into practice what you learn. If you have some coding that you need to write, try and do it with the new skills that you're developing. You'll be very slow at first, but you're going to pick up speed like these guys. And one of my interns actually got to 50 words per minute. He now types at 62 words per minute because he's integrated it into everything he does. So it doesn't come automatically. If you continue doing what you're doing, you won't make any progress, like you can see here with the red. Let me just mark it with a pen. So I was really trying to encourage this guy. Don't don't keep doing the same thing. You need to learn new skills, and when you learn new skills, you will experience a dip. And after that dip, you will then grow gradually and progressively and get better and better. Eventually, they plateaued, but then that just means that they ran out of learning material, but they kept going. Like you can see here, this guy managed to accomplish this 51 words per minute. So you can, and it's an investment that once you make this investment, just like being able to read, being able to write, being able to code, these become your skills. They become how you present yourself and how you show up in the world. So I strongly encourage you, invest time into learning how to type touch typing so that you can be more productive. You'll be surprised how much productivity is lost just because of your inability to type. Okay, let me stop sharing that. Today we'll be covering object-oriented programming, and our plan is we will introduce the class construct. Now, I'm using that very specific language because we've been talking about the three parts of any programming language. We have types, you have operations, and we have construct. Let me just share my slides so that then we can, let me see. I don't know where that has disappeared to. Okay. Okay. Let me share the slides. Just give me 1 second. I set this up properly. Oh, nice. So you can see my slides. You'll see an image of me. And I don't know what you're seeing now. Let's just see, what do you see? Okay, good. That's exactly what I want. So if you can hear me loud and clear, can I get a thumbs up? Let me just get a thumbs up from everyone just to make sure we are loud and clear. You can see my screen. Great, excellent. Did we manage to finish those programming problems from last week and the multiple choice questions? I noticed the engagement sort of has dropped. I really encourage you, please invest time into understanding those three constructs we looked at last week. We looked at if construct, which was for branching. We then looked at the for construct, which is for looping. You're going to use that everywhere. And then there was the def construct, which is for defining functions. And we said all of that is built on the idea that in Python we have, let me see if I can get that. In Python we have a standard structure where you have code blocks, and the code blocks are divided into two parts. You have a header and you have a suite, and the header is separated from the suite by that you have tabs that delimit each suite. Does that ring a bell? Do we have any questions before I proceed to something which is substantially more conceptually difficult? Any questions? You can type them in the chat. Please ask them now, because once we get started, we will be moving quite fast. Okay, no questions. That's fine. Let's go then. Okay, so today we are talking about object-oriented programming. And object-oriented programming is, when you read about it, you will usually find that it talks about presenting things naturally. And a lot of the examples that we shall talk about today will be in that vein. They will take things which have a tangibleness about them and try to present code in a way that takes advantage of their tangibleness. So that's it with object-oriented programming. And tomorrow and Friday, we'll then look at certain perspectives of object-oriented programming. So techniques, actually. So tomorrow we look at inheritance. And inheritance is a very powerful technique by which you can really minimize the amount of code you write by representing, capturing relationships, extending relationships. And then on Thursday, we will talk about polymorphism. And the idea behind polymorphism, it's a bit abstract. So I'd like you to follow along, because we are going to do a lot of coding as we go along today. So make sure that your IDE, whether you're using PyCharm or VS Code, is set up correctly. Please do not code on a mobile phone or on a tablet. Have a computer where you can actually code alongside what we are doing. So let's get started. So hopefully by now you are comfortable with functions. You know how to write a function. So we are building upon what we know. A lot of what you'll see is very conceptual, and that's so at the end of this, we should probably come up with, there will be exercises that you need to work through, and I would strongly, strongly encourage you to please do the exercises. If you find anything unclear and confusing, please ask now, because asking a question benefits everyone. And if you keep quiet, then you'll go with your misunderstanding or poor understanding, and it won't really help you. Okay, so we've talked about this. Now ignore the title. That was part of another a workshop, another training that I carried out, where I had emphasis more on the processing thinking. But we talked about types, operations, and constructs. Types, we've looked at several types: integers, floats, bools, strings, none, lists, dictionaries. Tuples, we didn't really look at. But for the most part, tuples are like lists which cannot be modified once created. So you can't append to them, you can't insert into them. You can create new tuples, but you can't really modify a tuple once it's created. Operations, there are operators, like what you see there. So the first ones here are numerical operators, and then we have the Boolean operators. Operators which are there's words and or not, and then you have those that test for membership, which are used on lists and dictionaries. And then we've talked about methods, and actually most functions will also be operations. They do things to things of different types. And then for constructs, we've looked at these three here. And if you've gone through the code quick wins, you will find try. There, I could give you some exercises on while. Lambdas are the same as def, but they are anonymous. And we haven't looked at with at all. So since we haven't looked at files, maybe what I can do is I can include some examples that you can, let me just make a note of that. So I will give you an exercise on while and with for opening and closing files. But essentially, there are three casts of characters, three key things that you should be aware of. Types are the representation things, and operations are what these representations can actually do, either amongst themselves or with other types. And then constructs are the things that the language gives us. This is where the keywords live. Okay, so any question to this point? So the plan is I'll actually split this into 3 days. First of all, we'll do some unmasking, and then today we'll do an introduction to OOP. Tomorrow we'll do inheritance, and then Friday or Thursday we're going to do polymorphism. So let's start by unmasking object-oriented programming. So you said every programming language has got these three elements, and the language is usually limited in types and operations. So why do we need objects or classes actually? Well, this is a new construct. It's a construct by which we can create our own types because the language is limited in types and operations. And what the class construct allows us to do is to write our own types. So whenever you have a class and you create a class, you're actually creating a new type. And when you define the methods for that class, you are defining the operations for that type. That's it. That's the whole idea. And the key point I want you to remember is that classes are templates. They are templates for creating objects. So two ideas here, the class construct, which is a way for you to write your own types, which have their own operations. That's idea number one. And then idea number two is that whenever you've now created a class, that class becomes a template for creating what are called objects. And this is where the object in object-oriented comes from. So idea number one is that your class construct allows us to write our own types and then with their own operations. And idea number two is that classes are templates, just like when you're baking a cake. I don't know if any of you has baked a cake, but if you're baking a cake, you usually will need to use these cookie cutters. Well, if you're making cookies, actually, you'll need cookie cutters to cut out the cookies. I think I have a slide that shows that here. We'll come to this later on, but this is an example of using the class construct. Now, the reason why we call it the class construct is because it has a similar header like when we looked at for the if and the for and the def. The header looks like this. You're going to have the keyword class, and then you're going to give your class a name. And then you have an option, this is completely optional, of specifying parents. And this is what we'll be looking at tomorrow. We'll be looking at how do we define parents from which we can derive our class. The suite of the class, if you remember from before, the suite, which is going to be the body, has three things. You can have what are called class variables. We look at this, don't memorize them. And then there are some special methods and there are generic methods. But essentially, you have variables or methods defined on the body or on the suite of the class. And the name of the class becomes what's called a namespace. Now, on the right here, we have an example class. So now we've called our class my class. Okay, so what I'll do, let me just share my full screen because I want to now go into my IDE. I'll share my full screen so that we can then dip into some code. So this is a class definition. We are defining a class. We haven't used the class, we are just defining it. So to define it, as we said, we use the keyword class. We give the class a name, okay? And then at the top, just like with functions, if you went through the manual, you'll see that you can provide what's called a doc string, and that's just to provide some documentation about it. It's usually a triple quoted string because it will span multiple lines. Then you can define what are called class variables. Here we've said some variable is equals to 0. So some var is a class variable. It's a class variable. It's a variable defined on the namespace of the class. So we'll see what a namespace is in a few seconds. And then we have this special function here, just like we saw before with functions, but it has a special way of being presented. It has these double underscores. And this is special because it is part and parcel of how Python defines classes. So this is what is called I'll call it an initializer. I won't call it a constructor because a constructor is actually defined with a different uh, function. And all of these methods, they start with the word self. We're going to look at this in practice, but for now, I'm just pointing out, we're just doing a lay of the land. We are walking through and seeing an overview. So here we have a special variable. We usually use the variable self. All methods, well, not all methods, but all methods that will act on instances of the class will start with the word self. Now, it doesn't have to be the word self. Now, Python is very permissive. You can actually use absolutely anything. And in some of the exercises, I'll show you, we shall make a transition from functions to classes by exploiting that. So we have a variable. This is just an ordinary variable, and this is a keyword variable. And then we have within it, we can reference some of the variables. We can set variables on instances of the class. And here we have a method. So this is a user-defined method. So this is now what we would now refer to as our own operation on the instances of the class. So we said that a class is a template, and that template makes objects. We also call the objects instances. They are instances of the class. Just like you could have, you are all students in second year electrical engineering. You are all instances of second year electrical engineering students. Each of you has got your own identity. So you are instances of the prototypical student. Again, we can have method docstrings, and our methods can return something. So this is just an overview. We have not just started coding. Now, when we go into coding, I really want you to follow along and you'll write with me. So two fundamental ideas is, idea number one is about the idea of the class construct, okay? And in the previous slide, we talked about the namespace. The namespace is like we can think of it as a container where we attach the different things. So here we have a method. That method is attached to the class. So the class becomes a container. So just like we saw with functions, functions are a container. They are a way to name a block of code. Well, it's the same thing with a class. It's a way to name a set of attributes or functions or the various things we define in it. And the methods are functions that act on objects. So this is another fundamental idea. Okay, so in terms of terminology, I'm being very repetitive here because I really want you to get comfortable with the language. They said a class is a template. So here is a cookie cutter. Someone has rolled out some cookie dough on a surface. You can see the flour at the top. And they want to make cookies. Now, if they want to make cookies, they need the cookies to have a certain shape. Otherwise, they wouldn't be cookies or biscuits. So what they do is they take a template like this one here that looks like a gingerbread man, and they press it onto the dough, and every piece that they make from the dough becomes an instance of a cookie. It's an object, okay? But they don't eat the cookie cutter. They eat the once the dough is baked and it's ready for consumption, they will eat those pieces of cooked dough. Those are the objects. And the class construct allows us to make these templates. So whenever you're instantiating, you're going to now create an instance like this. So you have a variable and you'll have an instance of the class. And the process of creating an object is called instantiating a member of the class. So all these will be members of the cookie class. Some of them will be of the Christmas tree class. Some of them will be of the gingerbread man class. Some of them will be for the snowflake class. And then once you have, we talked about the idea of a namespace. Whenever you hear the phrase namespace, think of it like that you have, it's a way to define name or variables that don't collide with other variables. So if I have a namespace called, let's say, gingerbread man, then I will refer to, I can have a lot of freedom within gingerbread man namespace, and I can come up with variables knowing that they won't collide with Christmas tree namespace. So a namespace just provides a way, just the way you see here. So this is the name of my instance, and I am referencing attributes using this dot, and I can use attribute one here. But suppose I came up with another instance. So I came up with another instance called, let's say, X, and I made X from my class, then X will also have attribute one, X dot attribute one. So this X and this my class are called namespaces. They are now the namespace upon which I can reference these attributes or methods. So that's what a namespace is. It's a space of names, a space which allows you to define variables or to reference variables without colliding with others. So here, X and my class obj are two different instances. They each define a namespace as a region where we can define names. Okay, I'm going to pause here. I've covered a lot of material. I know that your heads are reeling with all this content. I'm going to pause here so that we can now go through some questions. I want you to ask me questions. Anything that is not clear, anything that is cryptic, please ask. Please ask. Don't be shy. Any questions? Because we are going to now go deeper. So if something is not clear now, it'll just get worse. So please ask. Let me pick someone. Should I pick someone to ask, or should I just be patient and let you ask? Yes, good. Rubea, let's all give Rubea a thumbs up for asking a question. Does this mean a class can contain an attribute or a method? Does this mean a class can contain an attribute or a method? Yes, the class construct is where we will define our attributes and our methods. Now, I don't want to get into too many complicated details, but the funny thing is in Python, even classes are objects. And I know that is very confusing, but just keep it simple at the moment and just think that the class is our template. And for that template, we shall define attributes in it and we shall define methods in it. And some of the attributes, we can specify that they only show up in instances. They don't show up in the actual class. So whenever you you use it to make like you're making a cookie, it's the cookie that will have the attributes, but the class won't have the attributes because they only exist. So I'll show you, for example. Let's just go one step back. Okay, so give me 1 second. I change. So in this example here, it's a very good question actually. Um, this, sorry, let me change to the pen. And oh, I don't have my. Yeah, so this, let me highlight with a box. That'll probably be easier. Okay, good. So this particular, this is an attribute that applies to the class. That's why it's called a class variable. But this one here, because of self, it applies only to instances. Okay? And therefore, if we looked at the class, we would never see this var1. var1 only appears whenever we create an instance. So you see, like in this case here, where we've created an instance, here we've created an instance of my class. Now, in my class, it will then have these additional attributes. I don't know. Did I, maybe I confused things by using different. Let me go back. Did I use var1? I used var1 and var2, but I should have used attribute 1 and attribute 2. So let's imagine this is var1 here. The class itself doesn't have attribute of var1, but only the instances have that. Very good question. Very good question, because it does expose some of the internal details of Python and how Python has classes are objects too. And you have something called metaprogramming where you can now program at the class level. And that becomes a bit complicated, but we don't want to go into that right now. Any other question? Any other question? Please ask now. Okay, no questions? Thank you, Rubea, for that question. Excellent, excellent. So let's move now one step further. So now let's put the class construct into practice, okay? Now, I'd like us to think about a circle. This is what I meant when I said that whenever you're dealing with object-oriented programming, you deal in tangible things. And so we'll use shapes to play around and try and think through our experience of writing object-oriented programming. Now, suppose we would like to represent a measurable circle, okay? A circle that we can measure. I'd like you to write in the chat, what attributes would this circle have? We want to define a circle, and that circle is one where we can actually, we can measure the circle, okay? What attributes would this circle have? How do we describe a circle so that it is measurable? Excellent, excellent. Great work. Thank you for that. So the radius and diameter are actually interchangeable because you derive one from the other. If I knew the radius, I knew everything about the diameter. If I knew the diameter, I know everything about the radius. So there's no more information by defining both. Thank you very much, Timon. Thank you very much, Florence. Okay, now, are there any attributes that apply across all circle instances? Now, it's a weird question now when I think about it. So, what attributes would this circle have? And are there any attributes that apply across all circle instances? So, so for example, so you've given me the radius and the diameter. There are also other derivative. All circles are continuous. Very good. Excellent. I'd like to think that if you are drawing a circle, and this is just an extra thing I've added right now as I think about it, that you'd want to have a certain thickness of the pen that drew the circle. That's one thing that you could think about. there are also derivative descriptions of a circle, such as the area of the circle, the the circumference of the circle, um, maybe the color of the circle. The color could be something that you could define a circle. But you've got, I think we've got the whole gist of what I'm saying. If it's clear to you what we mean by attributes of a measurable circle, can I see a thumbs up, please? Any thumbs up just for me to know? Okay, thank you, Joanne. Okay, we are following. Great. Now, this is how, okay, then we also have position. I forgot about position, but position is a useful property. Where is the circle located in some space, maybe on a table or on a blackboard or on some virtual space on like on a screen? So this is a circle class. Um, the units, all circles will have the same units, right? And typically units are interchangeable when you apply some multiplier. So for example, if you have the units are defined in centimeters, but then you could convert centimeters to meters, you could convert meters to yards, you could convert yards to any other measure of distance, feet or whatever, right? But that would be an attribute that applies across all circles. And then when we define a circle, we shall give it a radius and it shall have a position. Now, what I'd like us to do is I'd like us to actually create this circle. So I'm going to open my IDE. Let me see if I can get it directly. And I'm going to open my slides. And maybe what I'll do is I shall open a copy of the slides so that it is visible here. And as we go through it, we can actually then. So let's write this out. I'm going to create a new module. Every file which ends with .py is called a Python module, just for the sake of clarity. I call it defining circles. Or let me just call it OOP circle. Okay, so there we are. Now, every time I write a Python module, I insist we should always use our import sys def main which will have a return 0. And if I'm going to type this out, even if my AI is actually helping me here, underscore main and I'll have sys.exit main. So I'd like you to, every time you write a Python module, please use this format because it will be instrumental. There's certain kinds of programs that only work correctly if you do it this way. So if you have the right practice, then you shall get those programs right from the beginning. So let's define our circle. We shall define our circle outside the main, okay? We shall, so class circle. For some reason, I think you can see my screen. And we are going to define the units are centimeters, okay? And we shall define in our initializer, we shall self, and we shall have the radius. We shall provide the radius, and we shall provide the position. By default, it shall be at the origin. And then we shall now, these will be made on the instance. So self is a variable that is associated with the instance. So that's why we say self.radius is equal to radius, and self.position is equals to position. Okay. Now, I will also give a special method here. It's called str method. This str method has got a very important behavior that it can confer on any object of that particular class. So str under str, it doesn't take any arguments. It only takes the instance itself. And we shall say we return, and I'm going to make an f string here. If you recall, I am a circle of size self.radius, self.units, located at self.position. Okay, so I'd like you all to type that out. I'm going to give you 3 minutes to type that out. Oh, someone has a question, Owen. Let's give Owen a thumbs up. Oh, thank you very much. Okay, what does the function init do, or what is initialization? Very good question. Initialization is the process of, so if you didn't have an initializer, you will create an instance which will be blank, okay? And when you create a blank instance, you will not have an opportunity to set some of the initial values for some of the attributes. In a lot of cases, you'll need to initialize something. When you're creating a circle, you want to initialize the radius. So we can actually ignore that. And so let's just, for example, let's just imagine I did that. Then we cannot now get the string representation of our circle because we haven't defined what the radius is, and we haven't defined what the units are, and we haven't defined what the position is. So the reason why you need an initializer is because you you want, as part of the creation process, not the creation process itself, but once the instance is created, we want to then set up some starting points for this. Okay, does that answer your question? Okay, so everyone, please take a few minutes, type out the code that you see on my screen in POTSYS, class circle, units is equal to centimeters, and so on and so forth. I don't want you to copy and paste. Please just type it out. It's part of your muscle memory. So I'll give you 3 minutes to do that. We'll be back at, I'll be back at 41, so 2:41. Okay, so hoping that you have actually typed that out. So now that we have the class, we want to create an instance of the class. Now, let me just emphasize again. So this is our class construct. We have the header class and then the name of the class. It ends in a colon. And then we have the suite here, which is indented one step inside, one tab inside. And we've defined our initializer, and we've also defined a special method called str. These are special methods provided by Python, and there's a lot of them, but these are just to illustrate a number of things. So now let's put this into practice. Let's do something with it. So we want to create an instance. So we instantiate. So we're going to create a circle, and we shall create it from our circle class. Now, in this case, what we'll do is we haven't provided a value for the position. So it will take the default value of position that we have here. So position will just be 0, 0. And now that we have our circle, we can print our circle and see what happens. So I'm going to run this by clicking the green here. If I run my OOP circle, and there we go, we have, I am a circle of size 5 centimeters located at that location. Now, what we could do is we could change the position. So we could say circle dot position is equals to, and we have to provide a pair of numbers. So this is a tuple, 0, 0. So let's give it like 30 minus 50. And again, we print the circle, and we'll see if we run that again. Now we have a new circle. Well, the circle has changed location. I am a circle of size 5 centimeters located at 30 minus 50. And we could change the radius now. So we could say circle.radius is equals to 17. And we could now print the circle again. And the circle tells us it's a circle of 17 centimeters located at that position. So here we've created an instance, this one written in small letters, which was assigned by this. So this was our template. We made a circle and we printed the circle. We did not initialize the value of position. We took the default and we then changed the position and then we changed the radius. So everybody, did that work out? So try that out with your code. Just create an instance, set a radius, and print out the circle and see that it behaves like what I've presented on the screen. I'll give you 1 minute to do that. Anyone who is lost, please now speak. Anyone who is lost, ask your question in the chat. Anyone who is lost. This is so powerful stuff. Like once you understand object-oriented programming, it all starts with the fundamentals. And I really want you to get the fundamentals right. So if you have any questions, please ask in the chat. Okay, so I hope you've managed to get something working. Now let's move on. Now that we know we can actually create a class using the class construct, we've now created instances or objects of the class. We've used the attributes and modified them, and we have also used some special methods. The under init, under, and these are called dunder methods. That's another name for them because of the double dunder methods. And then we've got the string method, which is to stringify. So the reason why it does stringify is because what actually happens is whenever you print something, print looks for the string version of an object. So what we've done is implicitly, it's like we have said print string of that. Whenever you try and print something, print will try and say, can I coerce the object to a string? And then it will check if it has an under string method. And if it does, it will then run that and then print that. So that's what we've essentially done. So this is the same. So I'm going to commit this to my repository. I'll say I've created and used a class a circle class. And I will commit that. Oh, wow. Okay, I hadn't added this to the repository. So, it's in the wrong place. Oh, that bother. That's not a problem. I'll just drag it out and put it into the Python folder. I'll do a refactor and it shows up here. It's in red, meaning that it hasn't been added to the repository. I use my shortcut of Command Alt A, and that now adds it, and then I can commit it, and I can use that string, and I will commit and push. It'll ask me, where do you want to push it to? It knows where I pointed it to. We did this in the first class, and I will push. And when I push it, it says pushing at the bottom. And now if I check in my Git, I can see that I have a couple of commits. I've created and used a circle class, which is for the OOP class. Okay, great. So there we go. Now let's try and make some progress here. So we've created a circle class. So the special function in it, we introduces two, I'd like you to, this is a task, introduce two new attributes, diameter and area, and provide the correct values for each. So we'll do this inside the init method. So let's just go back here. So let me put that instruction for you. So inside this place, so we want to create two new attributes of diameter and area. And I'd like you to set the values for those attributes so that now we can actually print. We'll say print the circle dot area or diameter. So let's actually do it in an F string so that we can, my area, my diameter is, and whatever that is. And we can then do the same, my area. Now you can notice it's actually giving me a warning that these are attributes that are not defined on the class. So we need to define them. So can you please define those two attributes, diameter and area, with the correct values? So that when I run this, right now when I run this, it'll give me an error. It'll tell me that we can't find those attributes. It says circle object has no attribute diameter. So can you add those attributes? And I'd like you to type in the chat, what will that code look like? Just the lines that will create those two attributes. What will they look like? Anyone want to have a shot? Anyone succeeded? Is this too difficult? Can you please? If it is too difficult, can you just give a thumbs up so that I know that you're finding it difficult? Excellent, excellent. Thank you very much, Robert. Okay, then. So self-diameter is equals to, well, it wouldn't be equal to diameter, but it'll be equal to something, right? What will it be? We don't need to define, but good point, because I see what you're saying, that if we add diameter to one of the input values here, arguments, but since we know that the diameter is a derivative of the radius, then we can just compute it on the fly, and that is 2 times the radius. And the same thing for the area, self.area is equals to, it won't be self. This is dumb. Oh my goodness, I didn't know that this AI can be so dumb. So it's 3.142 times self.radius. I'm surprised that it would be so dumb. Radius. Okay, so that's what we are looking for. Okay, now notice that this has changed. It no longer have the squiggles. And if we run that, we will now get, my diameter is 10, my area is that. So actually, we should have some units for that, centimeters, and maybe we should put self.units. Oh, sorry, circle.units. And here it's the same thing. It will be circle.units, and we shall add a circumflex with a 2. There we go, 78.55. Thumbs up. Did you have something like that? Does that make sense? Am I moving too slowly? Should I move faster? Okay, thank you, Dennis. Anyone who's struggling, please give me a thumbs down. I'm looking for anyone who might have some difficulty here. Anyone, please, thumbs down. Okay, good. I will proceed. Okay, so now we've done those two. So we now know how to create attributes. It's quite straightforward. So now let's move into proper. So the methods. So methods are functions that act on objects. Methods are functions that act on objects, but they are defined within the class structure. So the class construct has its syntax for accomplishing that. And we're just reusing the same def function that we used from before. Now, imagine if we wanted to calculate the area of a circle, and we defined our function just like an ordinary function. Our function takes an area. Okay, now what would it look like? So it would look like something like this. So where we'll just take the circle, we know we can access the radius, and then we'll have pi. We can actually get pi from the math.py library. So the import math, sorry. And then I will write a function, just a normal function, def area. And it takes a circle and it computes return that it's math.py times circle.radius. We can just say squared instead of just being verbose. Squared. Okay. So now we can calculate the area in another way. So we did that one internally. So we want a function that calculates area. And so now we can calculate the area. We can say print f, the area is area, and we just give it a circle. Okay. And actually what we could do is we could repeat this multiple times. I'm going to move this up here so that we can see the different areas and how they, so we changed, how many times did we change the circle? Oh, we only did that once. Okay, then that's fine. So we only have 2 radiuses. So if we run this now, we can calculate the area. So first of all, we did the area, we got it was 78.53, and then we changed the radius to 17, and now we have a new area there, 907 centimeters squared. Okay, so it's a simple function. We've just created a function, and once you've created that function, I want you to pay very close attention here. I'm about to do a switch, and this switch will confuse you completely if you're not paying attention. So we'll come to that in a second. Okay, so now we want to write a similar function. Now I'd like you to write a function for the perimeter or the circumference. So can you write a function just like I did for area? Write a function that calculates the perimeter, the arc length, L, given an angle theta, and the coordinates of the bounding box. Okay, so you're going to use what you have on the screen. So let's just step to the next slide. Yes, so I'd like you to write a similar function, just like the one I wrote for the area, which calculates the perimeter, the arc length, given an angle theta, And the coordinates of the bounding box, as you can see, there's an x min, x max, y min, y max. So write 3 functions. I'll give you 10 minutes for this exercise, and we'll look at what you've done. Okay, so 10 minutes, please try out this exercise. I'll be back at 6 minutes past the top of the hour. So we have 1 minute to go. Okay, so how did that go? Did the clues that I provide help? Thumbs up if the clues helped or if they were illegible. Maybe they were illegible. So let's go back. We want to calculate the perimeter. We'll write a function called perimeter. And it takes a circle and we calculate return. The perimeter it's as we had before, math.pi times, actually it's 2 pi r. 2 times pi times circle.radius. We want to get the arc length of a circle. And this is a bit tricky. We need to make sure that the angle is in radians. So we have the circle and we have the angle that we have, angle theta. I just call it theta. And so the arc length, so we have to make sure that theta is in radians. So how do we do that? Maybe we should have an argument called radians is equals to true. So if it is in radians, so first of all, let's calculate. So we return, it will be just angle times radians. So it is theta. So it will be theta times circle dot radius. Now, this was assuming that it was radians. So we need to have a branch. If radians, then we shall do that. But if it is not radians, else, then we now need to return something else. So first of all, you have to calculate theta in radians. And we shall use, there's a function in the math library called radians. It takes an angle and gives you the radians for that. So then now we can return theta radians times circle dot radius. And we can test these. So arc perimeter, arc length, and we have the bounding box. So let's see for the perimeter. What did we have? There's perimeter. So we can just print for a circle the perimeter. So I'll just say perimeter of the circle so that we can also see the function. And we'll do the same for this guy, arc length. So we can test this with an angle of, assume radians, let's say 30 degrees. Okay, theta is 30 degrees. And then we need the bounding box. So let's run this first. So you see the perimeter there is 106. And 106, I don't think we've done any other calculation for that. I think the radius was, let's just make sure that the radius was, I think the radius was, Joanne, you're writing on my screen. And the arc length here is 510 for an angle of 30 degrees. That doesn't seem right. Seems to be something wrong. So circle dot radius, circle theta radians, theta was circle dot radius. Ah, Oh, 30 is very big. Oh my goodness. That is so big. So let's say it'll be 2 pi, which is about 6. So let's 30 degrees is a third of pi over 2, which is a third pi over 2. Yeah, so it is much, much smaller. So let's say half pi. 45 degrees is what? Pi over 4? So pi over 4, that's roughly what? Let's just call it 0.8, for example. So we have 13. That makes more sense now. Okay. Okay, and the last one is a bounding box. So for the bounding box, define the bounding box of a circle. So we return, so we have to get x mean. So we'll do this all at one. No. We'll just do them one at a time. X mean is we have to get the x coordinate of the circle. So circle dot position, and the position is provided as x and y, and we subtract the circle dot radius. This one it was figured out correctly. X max is circle position, circle plus radius, and y mean is the y coordinate minus the radius, and the x is the y mark is y minus plus the circle radius, and then we can return all of them at once. Okay, so there we are. So and then we can just get all those values. So let's say we can print the bounding box of the circle. Any questions on this? So that's our bounding box 13, because we changed the center to be 30 minus 50. So 30, and we had 17 for the radius. So 30 minus 17 is 13. 30 plus 7 is 47 for the, I think that's the, what is that? Have we, X mark. So the minimum coordinate, the bottom left corner and the top right corner. Okay, any questions? Any questions? Any questions? Any questions? Do you all understand this? Does it all make sense? So I will commit this and I will say created functions for computing various properties of circles. And I'll commit and I'll push so that's up to date on my repository. Okay, great. So now that we can do that, what do the functions area, perimeter, arc length, and bounding box have in common? What do they have in common? What do you observe? If I just go back to the code here, if you look at all these functions, I'll just collapse this so that we can only see these functions. What do they have in common? Just look at that code. What do they have in common? There's one thing that is constant across all of them. And forget about the def and the colon and stuff like that. But in terms of the arguments, the way they have been structured, what do you see that is common across all of them? Anyone? What do you see that is common across all of them? The class circle is used as an argument. Correct. Very good, Owen. Excellent. Even one step further, take circle as a parameter. Excellent. Very good. They all take circle as a parameter. So these are functions that take circle as a parameter. I would even go one step further. Circle is the first parameter. If you notice all of them, even if, yeah, here we do have only one argument, but they all have circle as the first parameter. Okay? Now that is very instrumental because that will just show us something syntactically that we need to do. So just to remind ourselves, circle is a circle instance. Circle is an object of the circle class. Area, perimeter, arc length, and bounding box are all methods. They're really actually functions because they act on circle instances, okay? Now, what if we just put all these functions inside the circle code block? Will they work? They can test that out. It's a nice exercise. What if we put them all inside? I will just select them here. You can see them. They are part of the main code block, if you recall. They are not indented. But what if I just indented them once like that? Will they now work as methods? So all this code here will become invalid, okay? And the changes we'll have to make. So let's start by, I'll start by hiding this here, okay? And I'll start with this one here. So now we say that these functions are part of the circle classes namespace. They are within the circle class block. You can see they all align here. But now the difference is for us to call them, we don't call them as functions anymore, which is why our code here is invalid. We now call them, we now sort of swap this. Instead of calling it area take circle, we say circle dot, and we can actually eliminate this. Let me just fix it. Oh, sorry, I'm on the wrong one. I want here, this one here. I'll hide this out for now. Okay. But now I'll swap. I'll put circle first, and I'll put a dot, and I'll remove this. Notice that this is valid Python. There are no errors. Again, the only errors might be with my x min and x whatever. Okay, then it's complaining about what it expects in the convention. Like even for the type, there's a typo there, but we can ignore that for now. But this is all valid Python. We can actually run this. So if we run this, float object is not callable. Oh, sorry. Okay. We have two things. We have an area attribute and we have an area method. So I'll just hide this one for now. And if we run that, it works. And we just indented our code. How is that possible? That is crazy. Well, it has something to do with the naming of this thing here. You notice here, for these methods that we wrote before, their first argument was self. That's a convention. But as a convention, as I said, it's actually not a law. Python is very permissive. So we can actually change this now. Self means the instance. And every method takes an instance as the first argument. So we just need to change this here. And I'm going to use some fancy thing in PyCharm that I can click on the variable and I press Shift F6 and it allows me to edit all instances within that and it refactor that. Okay, so that's fine. And I'll do the same with this. I will allow the refactor and then I will do the same here. Click on the text, Shift F6, and again, I change that to self. And I think it'll ask me for refactor, it doesn't. Okay, that's fine. And I do the same here. Shift F6, self, and it changes that. And now it just makes it easy. I don't have to go typing everywhere. Shift F6, and I can edit all positions at once. And now it has reduced all those errors. Okay, I think it's only these ones here, and those don't really matter. Okay, so there we go. Now we have, it is perfectly valid Python. Now, what did we do? We took our functions and put them inside the code block. And then we've just changed the first argument from circle to self because every self is a circle. And that's it. We've just written methods on the class. So methods are just functions that take self as the first argument, where self refers to the instance of the class. So now four functions are in the circle namespace and will henceforth, they will be bound to the circle object, okay? So test that you can access them, they are all accessible, and compare them. The thing that we've compared is that the first argument should be self. Okay, and that's it. So that's very important. I really wanted to make that observation. So if you see, we always use the name self as the first argument just for consistency. We change our def area circle and it becomes def area self. So self just becomes the name of circle instances. So we've replaced all circle with self, and we've tested and our class actually works. So if we now, all we need to do change here is for these ones here, we now need to replace, oh, it now changed everywhere, including this. Okay, that's silly. So self.perimeter, sorry, circle.perimeter. And here we have arc length, it's circle.arc length. And we don't need that anymore. So we got rid of that. And here we have circle.bounding box, and we don't need any argument there. So if we run that, that works. So there we are. We've now gone from having a class. We had some functions. We put those functions into the body of, into the suite of our circle, and we changed the name of the first argument to class, to self, and now we have functioning methods, working methods. And there you go. So now I can commit this and say, now circle has methods. And I can push. Okay. So let's summarize. Let's summarize. I really want to summarize here now. A class is a template. We use the example of the cookie cutter. A class is a template from which we can instantiate objects. Okay, memorize that. The class construct is a container for attributes. We put things inside it. Someone asked a very good question. So we have attributes. Some of them can be class variables. Just know that they exist for now. We're not using them now. And some of them will be methods. And we saw that the initializer, the special method, can add extra attributes on instances, okay? We set attributes in the classes block directly or inside the init special method. There are other special methods. We've looked at str and under str, which give our object special behaviors. In this case, our special behavior was that the class is now printable. Methods are functions that take class instances as their first argument. This is not a good generalization, but it's useful when you're starting out. And they refer to the instance using the conventional argument named self. So self is just the name that they will always have as the first argument. Any name will do, but it may confuse other Python programmers. It's just good behavior. Okay, so now we've done that. Now we can go into some deep stuff. Okay, so this is our problem. We now know how to create a circle class, but now we want to do more. So we want to be able to draw shapes and write text on a canvas. So imagine if we had, this was a canvas, and our canvas was, it had the origin at the center, it had a height, and it had a width, okay? We had some background color, we had some shapes on it, okay? Each of them have their own position. So this is what we want to try and do as part of this exercise of understanding OOP, and also then integrating our understanding of inheritance. And last one this week would be on polymorphism. So here we are. We now have a rectangle. I'm going to give you 5 minutes. Write a rectangle class which has the following structure. It's got an initializer. It's got a width. Now notice all of them take self as the first argument. Okay, the width, the height, the position, self.width, height, position, and then we have area method, a method for the area, a method for the perimeter, a method for the diagonal, a method for the bounding box. So 5 minutes, I'll give you 5 minutes. Please, let's do this. I'll set the timer. Someone keeps writing on my screen. 5 minutes starting now. If you have any questions, please put them in the chat. If anything is confusing, please put them in the chat. Let me just check what's next. Okay, complete and show that it works. Okay. Okay, this will get really complex very fast. We'll have a canvas class, a text class, and then we'll do some drawing with our, okay. We'll probably move some of these things to tomorrow's class. The triangle, okay. I really want to get to turtle. If we can get to turtle, that'll be good. Okay, so you're provided the skeleton or rectangle class having the following: an implemented methods area, complete it and test that it works. Time is up. Okay, so are we making progress? Can I see thumbs up for anyone who succeeded? Thumbs up. Oh, very good. Excellent. Anyone who's struggling? Thumbs down. Can I see some thumbs down? Thumbs down. Can I see any thumbs down? No thumbs down. I didn't see any thumbs down. Okay, so I think that's a good sign. Okay, either you're not implementing or I'm now putting these for you to try out. So I would really like you to try these out on your own. They all follow the same idea. We're just making different types of classes. Okay. Unmarked, and I'll sign that. Okay, great. Okay, so here we are. So the other things that we need to do, so we've got a rectangle class. You can make a rectangle class. You can, for a circle, we'd like to be able to visualize some attributes, some graphical attributes of a circle. This is what I talked about, the fill. The fill is the color that will associate with the circle. So if you say a red circle, it will have a red fill. The stroke is the color of the boundary, the line that defines the boundary of the shape. So we'll add these. I'm going to leave this for you as an assignment. And the canvas. So now I'd like you to think about a canvas. Imagine you had a canvas. If you go back to this diagram here, we have a canvas which has a width and a height, and it's got a background color. Make a canvas class, not something too fancy, just a basic canvas class. It'll essentially behave like a rectangle, but it's a canvas class. It'll have special behaviors later on. Okay, so that is homework for you. And then last, I want you to implement a text class. A text class. Imagine you were to write some text onto your canvas. So here is some text in red. Okay, so what attributes should we assign to a text class? Well, there is the actual text, okay, the color of the text, the position of the text. So create a class text, which will then take those attributes and it will be placed on the canvas at some point, okay? So I want us to now, having gotten that idea, watch the video again if you're struggling. I'm going to post this on YouTube and then share it to the class. Now, I'd like us to shift gears and do some fun exercise here now. Python has a library called Turtle, and it's usually used for playing around. Like it's good for describing very, very simple graphics. It helps people think like a programmer. And there are two very important classes within the Turtle library. There is the Turtle screen library class. It's found on the Turtle namespace. So every package, the name of the package, depending on how you import it, that forms a namespace. So just like we talked about the namespace, then the class Turtle screen will then be accessible on the Turtle namespace. And this defines where to draw. So when you think of screen, think of where to draw, okay? This is just things for you to note. And then the raw turtle is actually the turtle. We're going to draw with the turtle, okay? And describes what to draw. It's an actual turtle, okay? I call it actual, but it's really not an actual turtle. Okay, that's fine. Now, let's play around with this. I want us to try something out. I'll create a new module and I'll call it Drawing with Turtles. So let's create a new module, new Python file. I call it Drawing with Turtles. Actually, yeah, drawing with turtles.py. Okay. Again, we will use our main structure, import sys. I'll add this to the repo. You see, it made it green. So import sys def main minor return 0 if name under equals under main under sys dot exit main. Okay. Now we're going to do some drawing. So let me open this on the side so that we can actually see. Good. So I want to draw a rectangle. Okay, I'm going to use the turtle library. So I'll import turtle. This comes with Python. It's a cool thing that comes with Python. Okay. And then now let's draw a rectangle. So I'll write a function just like what we have here, and I'd say draw rectangle. And I'd say turtle dot forward 30. And then, so copy along with me as we go. Turtle dot right 90. Turtle dot forward again 10. And turtle dot right 90. Turtle dot forward 30. Is that right? Yeah, and then turtle dot right 90. 90, and then turtle dot forward 10, and turtle dot done. Okay, so that's our function. We call it inside main, draw rectangle. Okay, so let's just see what we've told it to do. We have told it to go forward by 30, then right 90, so it will turn by 90 degrees, and then it will go forward 10, and then right 90. I think this is a good point where I can show the documentation for turtle. So I'm in the Python library. If I just go to the library and I search for turtle, I'm assuming it's still there. Maybe it's been removed. Okay, there it is, turtle graphics. Here it is. If I click on that, I see the documentation. It shows you can draw a star. You can draw all sorts of things. In this case, the way they have imported it is say from turtle import star. Means bring all the functions and dump them into the current namespace, which is a global namespace. So you just call things forward. But in my case, I've imported turtle. Look at the difference here. This is different from turtle import star. Okay, this is very different. If we say from turtle import star, then we shall just use a function like this forward. But because we said import turtle, we then use turtle.forward. Let me just make that clear. Okay. So if you say import turtle, you'll have to use turtle. If you say from turtle import star, then you can actually use all the functions directly. Okay. So it has a lot of functions. These are just, at the beginning, it shows you some examples of how to play around with it. How to say, there are a lot of how-to things here, but then the real methods are here. Forward, and there's some shortcuts, backward, BK back. And there's so many things you can do. It's just so much fun. You can have a lot of fun fooling around with Turtle Library. Okay, let's get this working and let's see what happens. So I'm going to run this. I'll run drawing with turtles, and it's going to do something. And I need to figure out what it's doing, where it is. Okay, so it drew on a different screen. So let me run it again. Hopefully it's going to open it in this page. Oh, no, it doesn't. It opens it somewhere else. Okay, that's a bit of a bother. But I don't know if I can zoom in. So maybe what I can do is I can make this bigger. I can add 100 to all the dimensions, 110, 130. The angles stay the same. So let's run that again. Oh, I wish you could see that. Okay. Let me share my other screen and then you'll see. So we'll see I want it to run on that screen. How does it do that? No, it comes up just so quickly. That's why it. Hmm. Yeah, that's a bit of a pain. But anyway, if you try and run this, you'll actually see it. It actually animates it. And you'll see the thing actually unfold. But what you're seeing when I show you the screen, you only see the final result, but it actually just draw, and then it stops. Okay. So why don't I give you 10 minutes to write that out? I'll leave it here open on the screen for you. Write that code and run it and see what happens. Okay, actually, let me do even better. I'm going to commit it and push that you pull it and then you can run it directly. So drawing with turtles. And I will push. So what you do is, what I would ask you to do is just pull it from the repository. Let me open a repository for you to see. github.com/Paul Python for engineers. You can actually just copy and paste. Let's just do that because of time. I'll just allow you to copy and only this one because of time, because I want you to see what it's doing. Just copy and paste that into your IDE, whether you're using PyCharm or you're using something else, and then run it. Yeah, so 10 minutes will be back at 51. Let me just be sure about this 1 second. Okay. I think we only have one other thing to draw a circle. And then I'll leave you with some exercise. Draw a triangle, draw a pentagon, and just write some text. Okay, so this is where we are. Yeah, so just copy and paste that text from, I'll paste this in the chat. Just copy and paste that and then run it. I'd like you to see what actually happens. It's really cool. Give a thumbs up if you have succeeded in getting the turtles to draw. Yes, thank you, Nashan. Thank you, Jordan. Thank you, Molo, Alex, Brian. Excellent. Fantastic. So did you actually see drawing? You saw how it draws. So that's fun. Okay, let's do the next one quickly. So this is drawing a rectangle. Let's try something else. Drawing a circle. So this is what you need to draw a circle. We have a function draw circle. The pen will be the turtle because the turtle is the one that actually does the drawing. If the pen is down, put the pen up. Then go to position 1528, put the pen down, and then begin the fill and set the pen color to red and draw with a fill color of purple, a circle of 60 and fill pen up. Okay, so we can do that very quickly. Let me just get my slides. So we want to draw. I'm going to draw def draw circle. Try and type it out so that you can get muscle memory. Pen is equals to turtle dot turtle. If pen is down, then pen up. Pen go to 1528. Pen down. And then pen begin fill. Pen color. American spelling. And here we have red. Pen fill color. Here we have purple. Pen dot circle 60. Pen dot end fill and pen dot up. Okay, keep doing this pen. Okay, and I'm going to call my draw circle and comment that out. Actually, I can draw them both. There's no harm. And I'll draw circle. If I run that, I draw this that, and then I have to close it for it to now draw the circle. I have an error. Turtle increment. What did I do wrong? Oh wow. No, that's not what I'm looking for. Pen is equals to pen is down. Pen is up. What is going on? Oh, this doesn't seem to work. Why? Drawing circles, it's a little bit me. Okay then. Okay then. Okay, let's just, I will hide that out. Let's try that again. Oh, very nice. There we go. And I can say, that'll done. Very nice. So that actually works. I'll push that. Draw a circle with fill and stroke. Okay, so if you go to the repository, you should now see that we have the new code. Drawing with turtles, we'll now have a function for draw circle. So in the interest of time, just copy that and then run that. But play around with that. I'll give you a couple of exercises. In fact, let me put those exercises for you. Draw a triangle, draw a pentagon, and write some text. So this you'll have to reference the documentation. Create an assignment, drawing with turtles. Okay, and no marks, that, and I will assign it. So you'll find all this on today's exercise. Okay. So that is it for today's class. What have we covered? Let's just do a summary. Can I get in the chat a summary of today's class? Anyone, just throw in some points. What have you learned from today? What have you learned from today? Anyone? Even just type one word. One word. Come on, guys. Introduction to object-oriented programming. Okay, thank you, Jordan. Thumbs up to Jordan. Jordan, can you tell us what is an object? Or anyone, what is an object when we talk about object-oriented programming? Instance of a class. Excellent. Very. Now, what is a class? We use the word to analogize what a class is. What is a class? Well done. What word did we use? There's a word we said beginning with T. Can anyone remember that? T. Template. Excellent, admin. Okay, then. And what did we say are the things that we add inside a class body? We use a word with A. Attributes. Excellent. And there are two types of attributes. We have those which are just variables, and then there's another one which starts with M. Methods. Excellent, Owen. Very good. So and then we looked at, let me just open my slides because I want us to walk through this. There's a lot that we've covered. It's conceptually very rich. Um, yeah, we talked about this was a slide. Sorry, I'm not sharing my screen. Um, so this was a slide which captured the idea of the classes are the templates, the cookies are the objects, and we it started with an example of a circle. We had some class variables at the top. We had some initializer method. They start with self. We have some arguments. Some of them are keyword arguments. They have a default value. We saw a special method called str, which gives you the string form of an object. In this case, we are printing I am a circle of size something. And then we looked at methods. We started off by writing functions, and then we pushed them inside the class. We just popped them in. And when we popped them inside the namespace of the circle class, they became methods. So we moved from having def area circle to def area self. And we summarized about that. That's what we've just talked about. And then this is what we are now working towards. We shall continue this work tomorrow and on Friday. So please do those exercises I've posted on the class. Please do them. We've looked at a rectangle. This is a repetition. We've talked about some graphical elements, which I'd like you to do as an exercise, a canvas class, a text class. And then for turtle, the big idea was turtle screen is where to draw, raw turtle is what to draw with, the actual turtle or the pen. We've drawn a rectangle using the turtle. We've drawn a circle, and I've given you some exercises. Draw a triangle, draw a pentagon, and write some text. Okay, so everyone clear? Did that make sense? Any questions, any concerns? On a scale of 1 to 5, how clear was this? I'd like to know. On a scale of 1 to 5, how clear was this? We've covered a lot of ground, a lot of ground. On a scale of 1 to 5, can I get some responses, please, in the chat? Okay, 5. Okay, good. 3. Okay, Musula, you need to help us understand what you didn't understand. Alex, 4. Thank you. Okay, 4. So practice amongst yourselves. As you do these exercises, please consult with one another. That's how these things will just, if you explain to someone, it will become better in your mind. If you are stuck and you ask someone, it will benefit the two of you. So please try and get little groups, sit down together, write this code, try out things, try your own experiments with the turtles. And I'll see you tomorrow, I think at I think it's 2 o'clock. You'll just confirm with the class rep. Let me just confirm that I don't want to confuse anyone. We are meeting tomorrow at tomorrow it is 2 to 5 p.m. No, sorry, 2 to 4 p.m. 2 to 4 p.m. tomorrow. Okay then. Thank you and bye.